So now that we have talked about waves as they approach the shore, I wanted to touch on this other idea, which is, I think, quite fascinating, and also something that impacts humans quite a bit. And this is called Longshore Transport. So basically, as the waves approach the shore, the energy displaces sand really, really, really well. Sand is extremely malleable, right? You can pick sand up and it moves in your hand very easily. It also moves very easily with water, turns out. So what ends up happening is in this surf zone region, that transportation of sand can leave a sort of almost wavy-like pattern on the beach area itself. And this happens mostly with places where the waves are not approaching directly straight on or parallel to the shoreline. So you can see here in this photo or in the schematic, how the waves are kind of approaching a little bit at an angle. And that little bit of an angle helps kind of transport sand down the coast. And again, so we call longshore transport. So generally what you would see at the beach are these evenly spaced kind of crescent-shaped depressions on the beach, which we call cusps. These are generally observed on sand and cobble beaches of these kind of quieter coves and longer, straighter coastlines. And really how they're formed is a little bit of a mystery. We kind of have an idea, but it's the dynamics of it are a little bit difficult to measure, which is kind of interesting. But so next time you go to the beach, see if you can see this, especially if you go to some of the San Francisco beaches like Port Funston or Ocean Beach, Baker Beach, any of those areas, and see if you can see this pattern on the beach. So at the very, very beginning of the semester, we talked about systems, right? And fluxes. So you have an in, you have an out. And it turns out that this is also the case with beaches and the oceans. So what we have here is something called drift sectors. So these are where paths that are traveled by the beach sediments as longshore transport transports them from their source to their area of deposition. So like in this schematic here, you can see that there's an eroding cliff. And so it's taking sediment, it's taking sand from this area, and then it's being transported down the region and then deposited into this little spit or little quiet bay area. And so we would say that then this region is in a dynamic equilibrium, and overall there's a little change in their appearance. So basically all of the sand in this area and the sediment in this area is kind of staying the same. So we wouldn't see too much differences in the beaches. But I will also note here that we do have two kind of types of beaches in a sense. So we have a winter berm and a summer berm. So in the wintertime, there's generally more storm action approaching the beach. And so that can take sand away. So it makes the beaches narrower. And then in the summertime, there's not as much storm action. So more sand is being able to kind of stay on the beach, which would then make the beaches wider. That's not really what I mean in terms of change in appearance. So maybe that's if you've gone to a beach and noticed that it's, especially in the wintertime, and noticed it's a bit more narrow versus going in the summertime. Overall, the amount of sand in that system, if it's in dynamic equilibrium, would be the same. Even though in their summer and winter times they would look a bit different, it would just be the sand is to be transported a little bit offshore. So when we take drift sectors and kind of put them into their own sectors, if for lack of a better word, we can call these circulations. So these are coastal circulations. So these are, this is focusing down in Southern California. So parts of the SoCal coast have been kind of divvied out into various circulation cells. So that's basically where sand is taken out of a system and then can be returned back to the beach in its own little cell here. However, there can be regions where they're of seaward transport that can then deposit the sand far enough offshore that it can't return and then is completely removed from the system. So what we can see here off the coast is not only do we have rivers coming in which are depositing sediment into the region, but then we can also have this sort of this taking away of sand and sediment, and it can be then removed far enough offshore that it's taken away from the system. So these basins here would not then recontribute to the sand or sediment load going back to the beaches. So this is a pretty important topic in terms of if you live right on the coast and coastal erosion, right? So a lot of our coast along the U.S. Is eroding on both the west and the east coast. And so we as humans have to take measures into our own hands, right? And try and keep beaches nice, big, and beautiful, especially if you, say, have a house that's right on the beach, or if your community that is like a destination location where maybe you have a bunch of resorts and things like that, then you might be interested in some of the ways that we keep the beaches from eroding away completely. So we have man-made coastal stabilization structures. And you have probably seen these before if you've gone to beach regions, especially at destination locations. So one method are groins. So these are kind of like almost, maybe you've seen them as piers, but basically when you put like this long structure in place, it allows for buildup of sand on one side of that region, so it builds that beach in. And this is because of the longshore transport that I spoke about earlier. So notice here you have an eroding beach on one side and you have this longshore current going down, and so if you were to build out some piers or just some stabilization groins, then that would allow for this trapping of the sand, which would then restore the beach. Then we have things called jetties. So rivers, as they deposit into the ocean, they can actually have kind of a buildup of sediment at the mouth of the river. Excuse me. And so if that's clogged, then communities can put in what are called jetties. So these kind of help channel that sediment further out from the direct coastline. And then that also kind of doubles as a sort of groin in a way where then there's trapped sediments, which also helps widen the beach a bit. And then there's also, you've likely seen, harbors, right? So these are put into place to absorb the wave action before it creates like this really interesting like calm space. And this can allow for marinas and harbors to house boats, and those boats will be less likely to be, I don't want to say harmed, beaten up by waves. And there's a perfect example of this, the Santa Barbara Harbor. So this is the Santa Barbara Harbor back in 1931. So they kind of built in this stabilization. Notice how not large the beach is, kind of over here in the center. And then in 1977, it's a very different story, right? So that's all because of that longshore current and deposition of sand and, man-made structures. Kind of interesting. So then we also have breakwaters. So I mentioned these before. So essentially, It's like a pile of rocks a little bit offshore. So not only does that help absorb wave action, but it can also allow for this sort of restoration of the beach regions. Then, of course, if you live in a tsunami-prone region, you might want to build a seawall. So these are built in to hopefully alleviate much damage from tsunamis if a tsunami were to come onto shore. These can be beneficial or not, kind of depends on how high the tsunami wave is, right? And then you've very likely seen this last one. It's called riprap. It's really fun to say, but essentially there's these big boulders that are put right along the shoreline to hopefully alleviate any further erosion. So, for example, if this riprap was not here, then this parking lot would likely be in danger of being kind of swept out into the ocean with any sort of big storm. And here's another example of that as well, right? You can see this eroding cliffside here, and an attempt at putting some riprap in. Then lastly, what I want to just chat about here are, so those are kind of, ways that we put something in place to hopefully alleviate any further erosion. There are some sort of softer solutions to beach erosion, what we call the 3 R's of coastal management. So the first one is regulation. So there's some California policies put in place. There's the Coastal Act and some various local coastal programs. I think maybe 2 semesters ago or 3, I don't know. I think it was when we were back in person. I forget anymore. But there was someone who came in, gave a talk at the speaker series who was very heavily into this coastal programs and rebuilding back beaches. The next one is relocation. This, as you can probably imagine, is a bit more on the expensive side. So you can relocate things like lighthouses or homes or businesses. Generally not the greatest thing to do, right? Because if you're moving a whole structure, it can be a lot. But it's not, in my opinion, as silly as this last one, which is renourishment. So this is literally the idea of taking sand from somewhere else and putting it onto the beach. It's extremely expensive, and it is also not helping the situation, really, because they're not taking care of the erosion problem. They're just kind of putting a Band-Aid over it. So in my opinion, I think this is the dumbest solution, but I'm not the one spending my money doing that. So here we are. But you can see in the short term, yeah, it sounds like a great idea. But if these communities don't put anything else into place to help keep growing the beaches back, then they're not going to have too good of a time. And if we were to imagine the erosion around the U.S., kind of what these things look like, the kind of pink color is severely eroding, orange is moderately, and the yellow is relatively stable. So for the most part, the Pacific Northwest is moderately eroding, save for a few locations. And then the poor South is, Louisiana in particular, is not doing too hot. And I don't know why they don't have all of Hawaii here. It's just showcasing Oahu, but this is a huge problem on all the islands of Hawaii as well. All right, so those are the ways that humans can impact erosion. Thanks for listening.